Hi, my name is Phil, and I'm going to take you through this series of topics. The first topic is the name badge. So let's move on. So we'll be exploring the microbit, and we'll have a look to see what it is. The BBC microbit is a pocket-sized computer, and it introduces you to how software and hardware work together. And on the top, you can see it's got bright LED lights as a display, and it's got 2 push buttons, and there's one touch button in the middle. So just above the heart there is the logo touch button, and on either side there's a label A, so that's push button A, and there's push button B, and it has quite a lot of sensors on board. So what's a sensor? Perhaps you can identify some sensors in the real world. And these features are called inputs and outputs, and they can be programmed and work together. So the latest microbit, that's version 2, and that's the one you have, adds sense sounding, and it also has a small speaker on it. So if you turn over the microbit, you can see the speaker on the bottom. So why don't you take out your microbit computer now and have a look at it. See if you can identify where push button A is and where push button B is. So best way to handle it is to handle it by the edges, and don't touch the parts in the middle. So to power our microbit, there's 2 choices. You can either power it with USB. So when you connect the USB socket on top with a USB connector, and it's called a micro USB socket, that connects to the computer and provides power to the computer. Alternatively, there's a small socket, white socket. So if you turn it over, it's best to see that, and it's on the right when you turn it over. And you can add a 3.3 battery pack using AAA batteries to the microbit. And that makes it more portable, and you can untether it from your computer. Okay, so the parts of the microbit, the most important part, the thing that makes it work, or the heart, is called the CPU. Does anyone know what a CPU is? It's a central processing unit. And the sensors, such as the light sensor or the push buttons, are connected to the CPU. It wakes up the CPU, says, I'm here, and listen to me. The CPU has muscles too, and these are called actuators. And one actuator is the array of LED lights that we've looked at. In order to make all that work, the CPU needs memory, and it comes in 2 forms. One is called RAM, and the other one's called flash. So what's RAM? What does that stand for? Random access memory. And the microbit also has communications, and it's got that in 2 forms. One is in USB. Another word for that is serial comms, or serial communications. And that's one way we'll be connecting the computer. That is, the Windows PC in the library is connected to the microbit by USB. So that USB has 2 functions. It has a function to deliver power, and it also has a function for communicating. That is, the Windows PC can talk to the microbit computer. But the microbit also has another form of communications, and it is in the form of radio. And it can there's two forms of that. One is called microbit radio, and the other one is called Bluetooth. So can anyone tell me where you will find Bluetooth? Yeah, you'll find it on your phones, and many computers can also support Bluetooth communications. So we'll be coding on the Windows PC, and we'll be using a program called Makecode. And once we've created the program, we'll be downloading the code onto the microbit over the USB cable. So we need to have that cable that connects the microbit to the computer. Okay, so let's introduce ourselves. And can you tell me a couple of things about yourself? Why did you pick this course? And what would you like to get out of it? Have you ever written a computer program before? And if so, in what language? Okay, about me. I'm a retired engineer, and I've also been a hobbyist in both electronics and computers. And when I did work, I worked in 3 different areas. The first area I worked in was medical electronics and biomedical engineering. And I delivered things like equipment for hospitals, including Westmead Hospital. And in transport, I worked on traffic control, like traffic signals and weather stations. And I use weather stations along the road to advise drivers when to drive safely. And I was also interested in bridges and keeping bridges healthy by adding sensors to bridges to tell you when the bridge was healthy. And in education, I worked for the University of Technology, and I was a lecturer there and teaching electrical engineering and also project management. So in this, over the next 8 weeks, we'll be looking at a number of topics. And topic 1 will be you'll make a name badge with your microbit. And we'll do that over 2 weeks. This week, we'll look at some of the concepts and demonstrations. And next week, we will go right into the programming and give you time to do that programming. And we will start working on the microbit and the electronics in topic 2. Although topic 1, the second week, we will do some programming. So what are the other topics? Well, topic 2, we'll explore time. And topic 3, we'll have a look at distance. Topic 4, the final topic, we will look at the weather. And all of these projects will be based on projects, things that you do and make. And hopefully that will drive your learning. And we will use the microbit or the Bit Gadget Kit for these topics. Okay, so the microbit can be a tool for a much wider goal, and that's to become more aware of the planet. And the United Nations is encouraging people to, and students to take a deeper interest in the world around us and in climate change. And they sponsor a project called Do Your Bit. And it's a challenge to achieving some of the global goals. So you might like to have a look at it. And there's a competition on right now sponsored by the United Nations, the British Council, and it's open to kids like yourself in 3 different categories. So you might like to go to that website and have a look at that. And here's some of the projects that kids have already been working on in this area. So there's one project in counting koalas. So it's been sponsored by the CSIRO, and the kids have become citizen scientists in being able to count the kangaroos in the area. So when they press one of the buttons, it actually counts the number of kangaroos in a particular area, and they can come back and see where they were on the map. Another project is a fish warning net. And the idea is that the LED lights can warn the fish in the area. And it's part of a project which is called Smart Farming. So let's look at the microbit in a little bit more detail. Quite a lot of information here, and you can see some of the detail on the side regarding the size, more information on the sensors, and we've got an accelerometer on board. So what's an accelerometer? Well, it's a sensor that measures acceleration. And a couple of other sensors, there's a magnetometer, and that measures the magnetic field near the microbit. There's a temperature sensor, so it can measure the temperature around the microbit. There's a light sensor, and there's the push buttons. So it's a pretty good start. You've got a few sensors there, and you can access them and add these to your program. So the actuators which are on board are the LED array. And if you look at it, perhaps you can count these yourself. How many horizontally and how many vertically? Well, you can count there's 5 in each direction. And it's not a lot, but it's enough to get you going. And you can scroll text messages on that LED array. And we've already looked at the communications. So on the bottom, we've got a edge connector, and it's 20 pins with 1, 2, 3, 4, 5 bigger pins, and they can be connected by wires to external sensors and actuators. And we've got microbit 2, which has got a little bit more on it, and it adds more memory, and it adds a microphone and a speaker. So it's a good idea to get used to the names of some of these. And the most important ones are knowing where the user buttons are. And there's the push buttons, and there's the touch logo. So good idea to find out where they are. And on the other side, perhaps you can find out where the CPU is. So it's called processor here. And where is the other connections and switches? Perhaps you can have a look at that. So for microbit version 2, that's the one that you've got. On the LED array, it's now showing a heart logo, and you can program that to be a number or a letter in the alphabet, or it can be a symbol like the one I've got. Perhaps you could show that. If you like something, you could show a heart logo on the microbit. So the important things are, A is the push button. That's push button A, and there's push button B. There's the USB connector and the edge connector. So they're the most important things on the microbit, and they're the parts of the microbit that you'll be working with. So what's Bit Gadget? Well, when we talk about sensors and actuators, we'll be using components from the Bit Gadget Kit. And what we'll do now is do a bit of a tour of the Bit Gadget Kit. So you might like to open the box and have a look to see what's inside. So can you identify any of the parts? So microbit fits on top of the Bit Gadget Kit. And when you open the box, you'll find that there's quite a number of components. So we'll go through those in time. You've got about 9 different sensors and actuators, and you've got about 7 cables. And there's an additional guide that you can use outside of the course if you want to explore a bit further. So the big board is called BitMaker, and that's where the microbit sits on top. And here are the sensors. You've got a rotary angle sensor, so you can put your fingers on it and turn it. And when you turn it, you change the voltage, and the microbit and the BitMaker can sense that voltage. There's an additional light sensor and a sound sensor. There's a push button. And the really interesting one is the ultrasonic sensor, and that can measure how far away you are from the microbit. And for actuators, we've got a mini fan, a vibration motor, and an LED RGB strip. The RGB stands for red, green, and blue. And you can program each individual light. And there are 30 of those on that strip. Why don't you open up the strip now and have a look at it? And all of these devices have a Grove plug at the end, and they plug into the cable, and the other end of the cable goes into the BitMaker. And you've got 7 of those. So let's have another look at the microbit and the BitMaker. So the microbit is connected to BitMaker in this way. So why don't you do that now? You get hold of your microbit and plug it in to BitMaker, and do it in the same way that I've got, that I'm showing it on this diagram. So don't get it reversed. So the LED, you want to be able to see the face of BitMaker, and you want to see the LED lights at the same time when you plug it in. And these devices are called Grove sockets. And there's your cable. So there's an example of the RGB LED lights plugged into port 2 of the BitMaker board. And on port 3, or port 2, we've got the ultrasonic rangefinder plugged in with the cable, the Grove cable. So these are the ports. BitMaker has 6 ports. So on the right, we've got P0, and in the middle, there's P1, and then there's P2. And actually, when you look at the Grove cable, you'll find that there's 4 wires there. So can anyone tell me what the red one's for? Yeah, that's power. And the black one is called ground. So that combination gives power to the sensor or actuator connected to the cable. And the other 2 are colored. One's yellow and the other one's white, which means that you can have 2 signal cables. So while the port is called P0, it actually has P0 and P1 signals going out to the Grove module connected via the cable. So on the left, we've got P8. There's the I to C cable in the middle, and there's P16. So you can see the full arrangement here of a microbit or a bit maker connected to microbit, and the USB cable from the microbit is connected to the computer. And here's an example of where we've added 2 Grove cables using the Grove cable to Grove modules. So on the right, we've got a Grove 4-digit LED display, and on the left, we've got a Grove BME 280. And that BME 280 has 3 sensors on board. It can measure outside temperature, humidity, and pressure. And we'll be using this in our final project to make a weather station. And we could actually go a bit further and have 2 microbits, one inside the house and one outside. And the one outside could be connected to a different shield. And this one's called the weather bit shield. And it connects to other sensors, such as measuring rain and measuring wind speed and direction. And the 2 of them can communicate. So the microbit indoors can collect all the information and send the whole pattern of weather to the computer via the serial communications. Okay, so what's the goal for topic 1? So we've already seen what a microbit is. We've discovered what a CPU is, and another name for a CPU, when it's really small like this, is called a microprocessor. We've seen how it's powered, and we'll be discovering next week how to program it using a program called the called Makecode. So what we want to be able to discover is, how do I use that microbit, and how it's powered and how it communicates. So they're the goals for topic 1. And for the name badge, we'll be creating a Hello World program. So this is, you often get this when you do a computer course. Your first program is to put Hello World onto a display. And we'll be using the LED array to show you your name on the computer. And we'll also use the push buttons, and we'll explore Makecode. So project 1, the objectives are to make a name badge that supports microbit and shows your name. So, and you can extend that by making it into a name badge with colored paper and cardboard, and you may be able to wear that using the batteries. So depending on how we go next week, we may be able to do some of that. So overall in these projects, we go through a cycle. And the first thing is to know what is our aim, what's the objective. We also want to be able to collect the hardware we need for our project and identify what's needed. We'll put that hardware together, we construct it, and we also look at the software construction. Then we test everything to see if it all works, and that we'll record the results. Did it work or didn't it? If it didn't work, well, perhaps we can discover why. And are there any issues that arose from that? Perhaps there's a defect in the software. And it's a good idea to keep a notebook and record your projects in this format. So here are some of the concepts we'll be going through. We'll be looking at what a program is and how it's divided into steps, and we sequence through that. We'll also be looking at a way of initiating an event. Like when you press a push button, you can get out of a sequence and you can then go to another part of the program which will react to an event. And we'll have a look at Makecode in detail. And the types of programs that we'll be working on are called a blocky program. And the alternatives are to use JavaScript and MicroPython. Here are your electronics. And here are the components that you'll need later to complete the project. And this is one of the blocks that we'll be using in Makecode. So you can see that there's two colors here, or three colors. There's an outside color, and that's an event program, which is run when you press button A. So when I press button A here, it shows on the LED array my name. That is, it's text, and you can change that text or program it to be something different. So looking at Makecode, these are the parts. We've got different areas on the screen, and on the left we've got a simulator. So when you put your code together, the simulator will try and show on the screen or simulate what your program can do. So the parts of the program, you've got the menu right on top, and there's the toolbox in the middle, and on the right is where you create your program. So from the toolbox, you drag the components across to the program area. And the last part is E. So let's go through those. There's A is the menu, B is the simulator, C is the toolbox, D is the program canvas, and E is a toolbar. And that's where you download, when you press that, you download your program to the microbit. So this program works on your PC, and Amy will help you get that working on the browser called Google Chrome. So this is what our first program will look like. We'll be using the toolbar and dragging across these components. So we've got one called on startup or on start. There's the forever, and there's the push button. So have a guess on what these blocks might do. So on start, when you power up or download your program, the sequence of steps under on start only work once. And you can guess what the other one's the opposite of that. It works forever. The steps go through one at a time, but then they repeat themselves. And the event block, and the example that we've got here, is when you press button A, the steps under that block will be executed, or they'll be run. And this is your program. This is all you have to do. So on startup, we're showing the string A on our LED array. And the forever one will show the string, my name is. And when I press button A, I will show my first name. And when I press button B, I will show my surname on the microbits LED array. And there's another look at the program. And We will go through this again next week. So that'll be all for part 1 of the first topic. So looking forward to seeing you next week.